taking a look inside of my 16-year-old Samsung 40-inch LCD TV with a cold cathode fluorescent light, or a CCFL backlight. It's quite interesting. I'm going to try to look through and walk through some of the components here. Probably going to get that panel off, especially because this is such a large complement of analog componentry. Why am I taking it apart? It's been encountering quite a bit of issues. It will turn on and then turn itself back off again and then turn on again. It does this weird power cycling thing. It eventually does turn on and operate, and it can operate for several hours without issue. But the most recent thing that we've been experiencing is weird color shifting or dark spots, non-uniformity in the LCD panel. And I thought at first it was the backlight, which is over here. This is the CCFL backlight, which is on the edge. I thought it would be down the middle, or I thought there'd be multiple ones. No, I couldn't find anything online that really explained where in proximity of the rest of the set the backlight is. And it seems like it's on this edge going across the screen this way, because this is obviously laying down with the panel facing down. And it's lighting it this way. I was thinking of getting a replacement backlight for it. They are available for like $45. I put the TV into its diagnostic mode and like the factory service calibration mode. And what I noticed is that everything seemed to be okay with that. When I put it on the white balance calibration and make the entire panel bright white, which it did, which was blindingly bright, and the whole panel looked uniformly lit. And I actually took my camera and exposure locked it to see if I could detect any non-uniformity in the panel, and I couldn't. So it really probably is not the backlight. So the next thing I started playing around with was turning off every single feature. I already had a lot of things turned off, like the fancy DSP functionalities for image processing and other things like that I don't want. So I just went and turned off everything. When I went and turned off the DNI lowercase e, the digital something something engine, I'll put it in the lower third, then suddenly the image got a lot better. I don't know what caused that, why that's happening. It seems to be what's causing it to have that particular behavior with the LCD panel. Now, it does not explain why the thing turns off and turns back on sometimes. The power LED blinks crazy, like it just blinks on and off like bizarrely when it's operating. It does make our soundbar, which is it's a Dolby Atmos soundbar. It makes that shriek and crackle, and then sometimes it'll take a really long time for the audio and video to sync seconds into the video playing. And when the video cuts out, like if there's a act break in the show or something like that, and it goes to a commercial, but it will again take seconds for it to sync back up again and restart. And we just bought a new TV, just a 4K panel, and Samsung. I'm not really that impressed with it. I mean, I knew it was going to be inexpensive, but I'm not really that impressed with it. And so I've decided to take this thing apart and see if I can fix this and get a little more life out of this thing, because I don't want to spend more money. This thing was $1,399 brand new 16 years ago. As I've been talking here, you're looking at the main power supply. So power comes in from the wall through here. Here we go. We got the line of neutral coming in here with a ground, and the ground is bonded to this whole massive metal chassis. I mean, there's like little rails for mounting all this stuff, and there's so much here. This is early days of LCD TVs. I think this is the first reasonably priced 1080p TV you could get in 40 inches. And the power supply here is pretty crazy. Modern TVs now with the LED backlights, they've got to drive the LED strips in the back. That requires some power, but this is driving a fluorescent tube, and that requires a high voltage power supply. So you've got a lot of stuff going on, a lot of voltage conversion going on here. So if we look right here at the beginning, we've got the two fuses. I just noticed that. There's a 250 volt fuse. There's two 250 volt fuses. I'm wondering if they have one on the line and one on the neutral, but I don't think so. I think this splits off. A lot of filtering going on here, and a gas discharge tube. That's awesome. No wonder this thing lasted so long. I mean, it's been on a surge protector or battery backup thing because it's just where it's situated, but two metal oxide varistors. Oh, I think I see what's going on here. They've got two metal oxide varistors, and perhaps the fuses are there in case these things go end of life and short out. Then the fuses will pop. But also the fuses providing protection for the rest of the system as well. And then we've got looks like a Pi configuration here because we got two common mode chokes. So So we got an X cap, common mode choke, X cap, another common mode choke. So I think it's a pi filter that they've got going on here to really suppress noise, because there's a lot of, this is more for noise suppression going back out, being injected back on the line than anything else, but also to minimize noise of anything coming in, any conductive emissions coming in. And there's another, this is a relay, I think we got over here. I think this might be our standby sleep relay. I don't see any, there we go. Oh, it's kind of hard to focus on that. Yeah, it looks like it might be a relay. I'm thinking that that is, all this has got to be obviously powered all the time. And then this is getting some wake up signal from probably the low power side, probably across this ribbon cable or one of these cables that are providing the wake up signal to power the rest of this board up. Wake up everything, all the high voltage stuff. So what we've got going on here past that relay looks to be bridge rectifier, which has got a massive heatsink on it, which is pretty awesome. Considering, you know, you look at stuff with the bridge rectifier on it today, may not be as efficient, but I don't know, they're still pretty efficient back in 2007. But there it is bonded to this heatsink. And then here, we've got dedicated FETs, and I think that's a diode there at the topmost position. That's setting up a DC power supply, and then this is the switch mode power supply here. This is the big beefy switch mode supply. Looks like this may be setting up the main supply, which then gets further passed along to switch the primary of this to drive high voltage to the fluorescent backlight, which I think operates at, they may not tell you on here. It's a CCFL, so I don't know what voltage. I mean, it's got silicone insulated wire. So my guess is that this might be pretty high voltage, maybe up to 600 volts. I don't know. I'd have to look that up. It's very hard to find information on this stuff just online, but it's got the silicone. You can see the double insulation here off of the connector, and that these are actually split pretty far apart. They don't come off one connector. Got to maintain some pretty good clearance and creepage to keep this from breaking down. Does this have a rating on it? This is IP40, and this sleeving has a rating on it. I don't think that is going to give us any information on like what the voltage actually is. Oh, I will talk about a couple more things real quick on the power supply side, because it looks like this does split. It looks like it has another, it looks like it might just be another inductor. You have this track here. You can see this black line. I do a great job of showing the separation between high voltage and low voltage. And I feel like what they're doing here is it does wrap around and then continue to provide a setup for low voltage for both the LCD panel, because remember, you got the LCD panel you got to drive, and the electronics on this board. So there's three big power supplies, at least, that I can see. One is the CCFL backlight, the LCD panel, which also operates, I believe, at high voltage, and then just like a smaller switching transformer for providing power to this system, which is still a pretty beefy supply, because this has got such a massive complement of analog inputs. There's so much analog to digital conversion that has to happen. Oh, plus your RF connectors. There's just so much here. Optical, I mean, that's, or digital to analog eventually. But even there's inputs for just like regular headphone jack style things. Anyways, I'm gonna take the shield off this, take the shield off. I just wanted to show anybody who's taking one of these apart that I removed all the screws. There was, I think, 4. Oh no, yeah, 1, 2, 3, 4, 5. And then I started lifting this off and it wouldn't come off. And I realized, oh, there's the VGA posts that have to come off before I can lift this thing out. Because the VGA port has like these threaded posts. It's crazy. Okay, so we got that shield off, and I'm looking at the back here, and after 16 years, you can see there's some warm marks. I think that might just be dust. No, that's not coming off. That's like it's a little bit of heat from the main two beasts here, but the shield's off. This is just for RF. This whole thing is for RF. There's so much analog that's going on in here that you need this shield. And it's got the little sponge at the bottom so that it bonds to the chassis, which is bonded to earth. So there's the shield. So put that down. So we have all our analog inputs, 2 HDMI ports, a third HDMI port here, USB port, composite, S-video, another S-video here, and VGA with headphone jack in, and then our optical M. There are block diagrams, a full service manual that I'm not sure when this TV was out that it was available. And from what I can tell, This thing was a beast because it had a lot of things that it had to be doing in parallel that might all, with a faster system now or a more efficient system now, could be all homogenized into one system on chip. And it could be even simpler still because you're not going to find any of this on a modern TV. The TV we just got, 3 HDMI ports, that's it. Nothing else, right? And a USB port. So all of this stuff, the analog to digital conversion, the muxing that's required, and for analog conversion to a digital display, I'm not sure what this interface is. It might be analog. I think for a 1080p display, I don't think you can do that. So it's maybe just differential signals for a digital display. But anyways, I digress. Back to here. We have 2 main chips here. Actually 3. I can't tell because this is a bit of a different board than the one that I have the schematics for, but you can see where there's a chip and then there's SRAM and a chip and more SRAM. One of these is the main system on chip, but it's not really a system on chip. It's just more of an applications processor, and it had, off-board SRAM, and it managed kind of a lot of the signals being moved back and forth, control, and more like ancillary functions. One of these other chips was really responsible for taking all the analog inputs, had a really powerful analog to digital converter. But anyways, this one, I believe, it was responsible for the video conversion from analog to digital, and then it had a buffer that it used to sync what it had converted back to either this processor or it would route it out through the display connection, depending on what source you're on, or it would be bypassed and not used if it was a digital signal. So if you're using HDMI, it didn't need to use this because it wasn't converting an analog signal, any of this, to a digital output. And then finally, I'm pretty sure it's this one. There's a dedicated chip for post-image processing. And this is the thing that I was talking about with that DNIE. This in the functional diagrams, I'm not sure if it's this chip or not. I'm pointing to things that are in relative positions. There's a board diagram that Samsung has, and I'm pretty sure there's a similar board, but there's a separate chip that's responsible for post-processing. So if you're going into your settings and you're changing it from standard mode to dynamic to movie, and you're playing around with the different configurations for how the picture looks, it's a separate chip. And then when you put the TV into game mode and it would say, oh, it's got an ultra fast 8 millisecond response time, that chip would be disabled. And then that would just come directly through one, it would skip one hop and then decrease the latency and mux directly out to the display, which is pretty cool. There's also, and maybe it's this, because generally the sound processors don't need heat sinks, but this looks like it might be a DSP. And there is a separate DSP that is just for the audio processing. Even though this thing has the 2 speakers, I think they're 10 watts a piece, 20 watts total, and it's got a sound chamber. They're downward firing speakers, so they don't sound the best. This would do I think this had SRS, surround sound, whatever, and it would take in the Dolby Digital 5.1 surround and give you a pseudo surround output, dedicated chip. There's a couple other parts and pieces here that are probably more supporting of just control functionality. A lot of these surface mount capacitors, I don't see anything that looks suspicious on this side of the board. I am wondering if after 16 years, there might be some issues with the RAM. Now, not particularly with the buffer. Well, actually, anything that's to do with analog signaling isn't being used anymore. I don't know if this part is functioning or not anymore. What I do know is that we are experiencing issues with the system not booting up, or it starts to boot up and then it restarts. And something, I believe it has to do with the main application processor, is just not happy. Whether that's due to its off-board SRAM freaking out every so often. Although I just realized that I'm pointing at the wrong thing. This might be the main processor here because I see a giant flash chip up there made by Samsung, and I'm wondering if perhaps I have these 2 flipped, which doesn't really matter. The functionality of what I'm describing is the same. They both have off-board RAM for general functionality, so I found that pretty fascinating because you won't find this on a modern system. You open up a modern system. I think Big Clive did one recently where he opened up one of these and he's like a modern TV and he's like, there's not much to talk about in here, but there's a lot more going on in one of these TVs from almost 20 years ago than anything modern. I just find it very fascinating. This system was always run in its highest energy saving mode, except when we were watching movies or things like that where we really wanted to like get the best possible picture. Everything was being driven as lightly as possible, so it only pulled about 100 watts from the wall, where it could, if you put it in its highest like blazing dynamic mode, it could do up to 320, 350 watts. So yeah, it has the capability. I'm also noticing up here this is the back panel of the TV, you can see that there are more ports that were available that they did not populate on this system. And they just covered them up with a label. That's pretty hilarious. I thought I had enough ports on it, but there's actually room for more. Okay, I'm gonna remove this cover. We'll take a look. So yeah, I had my meters out here ready to measure the voltage across the cold cathode fluorescent backlight. And I thought, I wonder if there is something on the board that would provide information as to like what voltage rails there are. And sure enough, there is. So we don't need to go any further. This is recently been plugged in, so I need to be very careful of where I'm touching. So if you look right there, you can see that we've got a 5.2 volt supply, a 5.4 volt supply, a 12 volt supply, a 13 volt supply, and a 2100 volt supply at 100 milliamps. So this transformer is outputting 2.1 kilovolts across these wires to this side of the board. So if I had put my meters on there, one of which is a category 3 600 volt rated, which would have toasted this thing, and then this Unity 61E Plus is category 3000 volt, category 4 600 volt. So no, neither of them would have been suitable for measuring that high of a voltage. So I'm glad I didn't put those across the output of that. But that is very high voltage. Not crazy high voltage. I mean, if we're talking about a regular tube TV, the step-up transformer for that is much higher. And same thing with your microwave oven, but still very high voltage. I don't see anything in here that would cause an issue. I do see a bit of dust buildup here. And then I also realized that I have things disconnected still. I thought I reconnected everything with the exception of the speakers, but I forgot that I have a control line up here. I believe that is for something on the inverter on off, dim, and a few other things. Not connected, ground, and then detection of 5 volts. So I don't think it would have powered up anyways because it didn't have the 5 volt control for it to turn on. I don't think it would have turned on the high voltage side of this. If anything, it's a good reminder to check that you have an understanding of what voltages you're going to be operating with before you try to measure something, because you might go beyond the capability and the safety rating of the measuring device you're using. This is the LNT 4061, manufactured in September 2007. I bought it in October 2007, and it's been running for 10 to 12 years really well, and then over the last 3 to 4 years it's been having these intermittent issues that seem to be getting more and more pronounced. I don't see anything that would kick me into action, into repairing anything here, unfortunately, and I really do feel like what's happening is predominantly on this logic board, and there's not much that can be done to fix it. One last thing, I just realized, plug that connector back in carefully, and then I'm gonna power this back up. We hear it click, there it goes. And I'm gonna turn it on. I'm gonna see if we can see anything on that backlight when it's, oh, there it goes, it's going. The TV's on. You can see the light coming through there. It's just static right now because it's on the tuner. You can see it. It's kind of a rolling shutter effect because I don't see that flickering there, but you can definitely hear that high voltage transformer. Wow. This is plugged into a battery bank right now, so everything's floating reference, a little safer, but don't want to get too close to this thing because, you know, don't want to get zapped. Yeah, that's crazy. I just realized it's a Rev 0.1 released on 12/21/2006. That's it running. You can hear that transformer going. I'll turn it off so you can hear it stop. There it goes. Hope you enjoyed this video. If you did, please like and subscribe, and I will see you in the next one. Take care.